Hello students, good afternoon. Please let me know who all are there. Very warm welcome to the GATE Academy, to the GATE Score Booster session of Geotechnical Engineering. You know the agenda behind the session. You have already got enough sessions already, right? We have seen with transportation engineering before. We have seen with the irrigation and hydrology. And today we are here with the geotechnical engineering. Gusaji is there. Good afternoon. Krishna, good afternoon. Yes, we'll wait for a few seconds. Let more students join, okay? So as we know, geotechnical engineering is one of the very important subject for GATE examination. The weightage is obviously more than 10. We don't know how exactly for how much marks, how many marks they may be asking the question, but definitely we can expect around 12 marks, 13 marks and all, right? So very important thing which I want to tell you, what generally all the students used to do, since it is very important, like weightage is around 13 mark, 14 mark, most of the students will spend a lot of time on geotech, but at the same time they will skip some other subject. So don't do that. Give equal importance to all the subject, but obviously you have to do more questions on geotechnical engineering. While doing the revision, you have to spend definitely more time on geotechnical engineering. It doesn't mean that you can skip some other subject and study this because the weightage is higher. The very important thing is what we have observed when we are analyzing the previous GATE papers. If they are asking, for example, if they are asking for around 12 mark or 30 mark, around 6-7 mark you can easily score. Easily in the sense, not simply. If you are properly studying the concepts like other subjects, if you are attending, if you are taking any online classes, or if you have any, if you are referring textbooks, whatever, if you are properly learning it, easily you can score around 6-7 marks. The remaining 6 marks, definitely it may be somewhat tricky, or some questions will be really tough. Geotechnical engineering is like an ocean. They can ask anything. They can combine more concepts and ask you one question. Okay, more complicated topics, concepts are there in geotechnical engineering. Okay, whenever it comes to pile foundation, lot of things are there. Okay, consolidation. But even if you are not studying those complex portions, then also you can score around 60 to 70 or 80% of marks, which are going to come from geotechnical engineering. Okay, understood? So just focus on that 8 marks and make sure that you are going to get that 6, 7 or 8 marks, which are going to come in the remaining. It will completely depends on how we are preparing. Okay, some important equations are there, lots of equations are there in geotechnical engineering. What I'm telling, by looking at some revision session or by looking at the previous GATE papers, don't get depressed after seeing the geotechnical engineering questions. Definitely there will be complex questions, but don't get depressed. Okay, the remaining 8 marks you can easily score. So we are going to focus on that 8 marks mainly. Plus I will tell you so many hints to score the remaining 4 or 5 marks. Okay, and I hope we are doing the session in 3 parts. Okay, this is the first one. Second and third part you will be getting in the coming days. You will be getting the notification. Most probably this next session will be day after tomorrow. You might have already got the link in the channel. So those who are watching the video who have not subscribed the channel yet, please do that and click on the bell icon also. You will be getting that notification whenever live classes are happening. Okay, and I hope through 3 parts of 2 hour, we are going to complete almost 99% of geotechnical engineering. We cannot tell that 100% because no subject we can finish within 6 hours and all, particularly like a subject like geotechnical engineering. But definitely we are going to cover all the important topics, and I'm 100% confident that you will also be getting that confident when you are entering into the examination hall. Okay, so more students are joining. That's why I was taking a few seconds for giving some introduction. Right, Sumitra, Vikas, Chetan Kumar, I'm sorry if I missed any name. Good afternoon, everyone. So shall we start? Sam Koshi, good afternoon. Shall we start? Shall we go to the first question? So since most students have joined, one last word, the agenda behind the session, if anyone don't know, nothing but we are going to solve a lot of questions. So through the questions, while solving question, we will explain few concepts and I will tell you how to approach some particular questions. How can you tackle the trick, how we are going to proceed by reading a data. Okay, that all things we are going to discuss. And maybe at the end of that third session, you will be definitely in a confident state, okay, for geotechnical engineering subject. Right, so shall we start? Anil has joined, Narendra, Sajid, good afternoon everyone, Ankit, Anil, good afternoon everyone. Again, I'm sorry if I missed any name. Kumar, Pankaj, good afternoon. So shall we go to the first question? Ready? Everyone, please share the link with your friends also. Let them also watch the video. Right, so without wasting much time by giving so much of introduction, we can just go to the question. Very easy question, direct question, not complicated thing. You have to be very much confident in your foundation basics, okay? If you're strong in foundation, if you're strong in basics, then if you don't know some particular concept which are asking in the exam, you can frame the equation in the examination hall itself, okay? Or simply by looking at the options, you can just predict whether this can be the answer or not. Like that, you can just give some guesses, okay? So just to boost up your basics, I have added this question. Just go through that, understand what we have to do, properly read the question. I'm just giving you a few seconds to go through the question and start solving it. After a few seconds, I will also start solving along with you. No need to write the entire question. Okay, just take down the data. You will be getting these questions and videos, everything later on our channel. So no need to take down the entire question, just take the data and start solving it. Samkoshi, yes, like we will be having 3 parts. You just watch the 3 parts, you will be definitely getting that confidence. I'm not telling this is sufficient, this is the last word, okay? It's not like that. Geotechnical engineering is a very big subject. But those who have already prepared, if you are watching this video, definitely you will be getting all those concepts get brushed up. And those who have not started anything, okay, your preparation, definitely it's going to help you like anything in the examination hall, trust me. Right? So I hope you have already started solving it and you are getting some answer. So I will also start solving now, right? Hope you have already taken the data, everything. Yes, anyone is getting the answer within this time? No problem. So I'm also solving along with you. Those who are solving, you can solve, no problem. Okay. The first thing, degree of saturation, very basic, okay? It's not a complex question as I've already told you. What is degree of saturation? Volume of degree of saturation is equal to volume of water out of the total void space. We are having, see, this particular diagram, we call it as phase diagram. Sometimes it may be only 2 phase. Definitely solid will be there. No? If you are simply taking the sand, whatever you are seeing, that is soil solid. Sometimes we'll simply say solid, sometimes soil solid. That will be there. Definitely some void spaces are there in between. That's why if you are adding some water to the soil, it is getting stored inside the soil. You know? Because so there are some void space. Definitely there will be void space. It is not possible to make 100% solid, which means it is not a soil. It may be something like what I can tell, some solid object may be there, no? Like that. Okay. So inside that void space, how much portion is water? That we call degree of saturation. Tell me how much it is, everyone. Okay, I'm getting answers, but I should say I'm not getting the right answers. Tell me how much is the degree of saturation then? Volume of water divided by total void. What do you mean by total void? Air plus water is nothing but our void space. Okay. So how much it will be? 9.5 centimeter cube divide by how much is total? 4.5 plus 9.5. Very easy. No? Very, very easy. 0.6785. Yes, very good. I can convert that into percentage, 67.85. Right? Very simple, very, very simple. But that itself can be a gate question. Simply they can ask. So many times they directly asked what is the equation for. I will tell you those questions. Okay. So many times they just directly ask the equations for 1 mark and all. They can ask such silly type of questions also. Don't think that it is a gate question. It's a gate exam. They will ask complex question. No. Okay. So first one, whether it is correct, obviously option A is correct. So shall we move to the next question? We got the answer, no? That's it. Very good. Now in this year onwards, we have MSQ type of question. Whenever you are seeing different things in the options, you have to check everything. If all the options for a degree of saturation is this much, this much, this much, then we can just go to the next question. But whenever they are giving different thing, properly check whether the other options are correct or not. Okay. So how can I calculate the porosity? What is the equation of porosity? Don't look at your notebooks. Don't look at the textbooks. Don't look at your short notebook. Just try to rewind. Okay. Try to brush up the things and solve it. Okay. What is the equation for porosity? Everyone? Very good. Volume of void divided by total volume. Okay. If I am putting volume of void divided by volume of solid, what it is? If I am putting volume of void divided by volume of solid, what it will be? Very good. This is known as void ratio E. Whereas if I am taking the denominator as total volume, nothing but porosity. We have some relationship with this too. We are going to discuss it. Let it be there. So now tell me what will be the answer. Everyone please comment. Solve it fast. No need to waste so much of time on this question. Everyone please comment. What is the answer you are getting? Yes, very good. 0.583. So can it write it as 58.3%? Okay, anything is fine. So whether that is correct, they are given 1.4 means decimal. Okay, not in percentage. They have given in terms of decimal 1.4. Obviously that is wrong. We got the answer as 58.3% or 0.583. Okay. Now go to the next one, water content. How can we calculate the water content? You should remember what is the equation of water content. Very, very, very important. Weight of water divided by weight of solid. Okay. Very, very important. Water content. What is the weight of solid? That is given 22 gram. 22 gram. Now tell me what is weight of water? Not given, huh? Yes, not given. What to do then? Should I skip the question and go to the next question? If I'm sitting in the examination hall, data is not available, sir. What to do? What you will do, tell me. Weight of water is not given in the question. Should I assume some simple sum value, or should I calculate it using some other big equation, or should I skip the question? What to do? What you will do if you are sitting in the examination hall? Anyone please comment what you are going to do? Not getting any answer? Fast, fast, fast. What you are going to do? Very good, very good, very good. Yes, now I started getting the answer. We know the density of water is equal to, sorry, we know the unit weight of water is equal to density also fine, no problem. We know gamma W is equal to 1 gram per cc, unit weight 1 gram per cc, rho into g. If I'm taking the density, then 1 divided by and all will come. So 1 gram per cc. Cc means what? 1 gram per centimeter cube. That is the unit weight of water. Very, very important. We can write it in many terms like 9.81 or 10. Sometimes we'll take 10 or 9.81 kilonewton per meter cube, or we can put it as 9.81 into 10 raised to 3 Newton per meter cube. We can also put it as around what I can tell, instead of putting 9.81, sometimes if you are telling that it is take 10, then it will be 10 raised to 4 random. Okay, Newton per meter cube. These things are very important, remember. Now you tell me, if this water is having a volume of 9.5 centimeter cube, how much will be the weight? What is unit weight? Nothing but weight per volume. Okay. Now tell me how much it will be. Yes, very good. Yeah, we can also write it as in tons. Yes, okay. 1 tons per meter cube. That is also correct. 1 ton is equal to 1000 kilogram. Okay, you can just convert into kilogram also. Understood? That is also correct. Yes, very good. Okay. Now you tell me how much it will be. Yes, very good, everyone. Definitely that is going to be 9.5. If they are giving some value, for example, some 9.6, 9.4, take as it is. If it is not given, then obviously gamma W is equal to 1. Sometimes some slight variation may be there. No? That's why. Okay. So we got that value also, 9.5 gram. Now tell me how much is the water content? 9.5 divided by 22, 43 point, and now something you are going to get 43.18 percentage. Very simple question. This is just to boost up your basics. Okay. What is the given option? That is also wrong. Now, should I check the last option? I understood that it is a multiple selection question, MSQ. Should I check the last one? Obviously, more than one will be right answer, no? So, should I check it? Should I check it? Obviously, very good. Obviously, we have to check. Multiple selection question doesn't mean that definitely at least two will be correct. Nothing like that. Sometimes only one also can be correct. Obviously, one will be correct. Okay. Either one or two or three or four. Okay. So we have to check every answer. Okay. Right. How can I calculate gamma saturation? Saturated unit weight. What is the equation? Gamma W into general equation is G plus E SR divided by 1 plus E. So by default, bulk density. Na? So whenever gamma saturated is coming, degree of saturation will be equal to 1. So how much you have to take? Gamma sat is equal to gamma W into G divided by 1 plus, sorry, G plus E divided by 1 plus E. Hai so check whether all the things are given or not. Whether they have given everything or not. Everything is given or not? No, we have to calculate gamma W, we know. See, we can calculate in many ways. Okay, if you have the concept, you can calculate in many ways. Simply, just to give you some idea regarding all the things, I'm just writing everything. Okay, gamma W, we know 1 gram per centimeter cube. I'm simply putting 1 there. Do you know what is the specific gravity? Don't know. Do you know what is the void ratio? E. Yes, that we can calculate. Now, here we have already written that. How much will be? Can you calculate the void ratio and tell me? 14 divided by 4, it will come now. Are you getting 1.4? Yes, very good. G is equal to 2.2 will be getting. Very good, very good. We got E value 1.4. Let it be there. So 1.4. As of now, G is unknown. 1 plus 1.4. Now what to do, guys? We don't have the value of G. What to do? What can we do to calculate G? Very good. Void ratio equation. We have one more equation for void ratio. That is that Wg by saturation. Okay. Wg by SR. If you have a particular soil from 0 saturation to 100% saturation, your void ratio will remain same. Because what do you mean by void ratio? How much volume of void divided by volume of solid. Volume of solid will remain always same. Volume of void will remain same till saturation. Hai na? Till saturation, what will happen? If I am adding more water, what will happen? Volume of air will decrease, but volume of water will increase. If I am adding more water, still the void space remains same. In that void space, if I am adding more water, air is getting decreased, water is getting increased, but the sum of both air plus water is nothing but our void. Volume of void also remains same till 100% saturation. If even after saturation, if I'm again adding water, then what will happen? Then volume of water is again going increasing. So void space also will increase. Hai na? So till saturation, whatever be the saturation value, your void ratio remains the same. So we know some water content at this particular value of saturation. And if I'm putting saturation is equal to 1, then corresponding water content I should know. But I don't know that. So what we can do? From here, we know what is the water content. 0.4318. Specific gravity will be obviously constant. This is specific gravity of solid. That is constant. What will change? This W and water content may change. What is the corresponding degree of saturation? Corresponds to this. Everyone please comment. We have already calculated it. Yes. How much is that? 67.85. Now corresponding at that particular state of water content, what is the degree of saturation? So how much it is that? How much is that? 67.85. So I'm putting in decimal. Clear? Void ratio we already calculated. From dry state to saturation state, void ratio will remain same. We already calculated how much it is. 1.4. So from here, you can easily calculate our G value. Tell me how much it is, everyone. Very good. 2.2. Okay, Badia. Getting? Now all the unknown we got. So substitute that 2.2 here. Calculate. Tell me how much is the gamma saturated value. Everyone please comment. Fatafat. 14. Sorry, 1.5. Yes. Okay, approximately are you getting 1.5? What will be the unit? The unit will completely depends on at what unit, I mean, in which unit you are substituting gamma W. Specific gravity is unitless. Void ratio is also unitless. So this one I have substituted in 1 gram per cc or 1 gram per centimeter cube. So this will be centimeter cube. In the question it is given kilonewton per meter square. Sorry, it should be kilonewton per meter cube. Okay. Unit weight is meter cube. Kilonewton per meter cube. Just check it. How can we convert? Or simply kilonewton means 9.81. You can substitute here 9.81 kilonewton per meter cube. Or finally you can just multiply with. So 1.5 into 9.81. Everyone please comment how much you are getting. 14.7. Okay. All are getting the same answer. All are getting the same answer. In the equation, you cannot put saturation is equal to 1 because see, if you are putting degree of saturation 1, then the corresponding water content you have to take. Do you know what is that water content? No. We have calculated this 9.5 gram water content based on this particular diagram. The complete volume is 4.5 plus 9.5. In that complete, we have this 9.5 only. Correspondingly, we have calculated. If you are putting saturation 1, yes, then obviously you can calculate what will be the water content at corresponding 100% saturation. Then you can put it, obviously, no problem. Okay, till degree of saturation, it's same. Understanding? Gursaj, are you clear? Okay, yes, very good. Anything, that's what I told. If you have the concept now, anything you can do. That's what I want to tell you. Majority of the time, what students used to do, maybe in my class or in YouTube sessions, you may be looking at some materials solution. Now, whatever be the institute, you may be looking at the material solution and you may be thinking, why they have done like that? Why I'm not understanding this solution? No need to understand their solution. Just you have the concept, solve your own. Okay, you don't have to follow the same step which I have solved. You can do it in your own. See, void ratio, we have, I'm just showing you something else. Before that, tell me whether option D is correct or not. Yes, no? Okay, so what will be our answer here? A is correct, D is correct. Clear, everyone? Please comment clear or not. Whatever we have discussed is clear or not. I'm going to give you some extra point also. Everyone please comment so that I will understand whether my speed is okay, whether my explanation is okay. Okay, fine. Understood now, everyone? Now you see we have different equations for the relationship between void ratio and porosity. That itself can be an MSQ question. Okay. What I used to remember, simply 1 by n minus 1 by e is equal to 1. This is how I used to remember. It's up to you whether you want to whether you want to remember this or you want to remember something else or not. Okay, so many ways we can write the relationship between E and N. Simply see, if you want to look at the equation, if I want an equation for E, what is E? What I can do? 1 by E will be equal to 1 by N minus 1. That is going to be 1 minus N by N, which means E is equal to N divided by 1 minus N. That's it. Within 2 or 3 seconds, I can make that equation. So that you don't have to by heart what is N equation. Simply, if I'm rewriting it again, how can I write? I want the equation of N. So 1 by N is equal to 1 plus 1 by E. So 1 plus E divided by E, I will be getting N is equal to, that's as simple as that. Okay. Or also you can remember 1 by 1 plus E is equal to 1 minus N. So like that, they can give some equations in the options and they can ask you which of the following relationship is true. So if you are looking at such equation, you may be thinking that it is wrong, but it is correct. That we will discuss in some other topic. Just I'm telling those who have studied the equation of critical hydraulic gradient. And now you might have seen this equation G minus 1 divided by 1 plus V. I'm going to show you this equation later also. We can also write it as G minus 1 into 1 minus N. Understood? Because 1 by E is equal to, 1 by 1 plus E is equal to 1 minus N. Understanding? So like that, they can ask you a question. See, you can just check here. We calculated now E is equal to, using E equation we have calculated. Suppose in the examination hall, you are getting confusion. Should I use 0.67 or should I use 1? Should I means 100%? What you can do? Simply leave it. No problem. That's what I told you. You should have the concept in you. No need to follow any material solution. Simply we calculated N value. How much was N value? 0.583 something. Now, what was the exact value? If I am taking, it was 14 divided by 24. 0.58333 is going like that. Okay. So we got that value. Now you just calculate what is E. E is equal to N divided by 1 minus N. If you are using that particular equation, just calculate it and check it. How much you are getting? Everyone? How much it will be? Divided by 1 minus 0.58. Are you getting the same answer? 1.3999, approximately 1.4. It depends on how accurately you are taking N value. Getting now? That's it. So now you understood whether I have to use this saturation SR equal to 1 or this 0.67. See, whenever you are getting confusion, that's what I told you. If you have the concept now, you will be getting that. Okay. No need to follow anyone else's solution. Have your concept, do it yourself. Now is it clear? Everyone? Okay, like this, any equation you can use. Okay, now? Now tell me if they are asking what is the submerged density. Gamma submerged. Saturation value we calculated. They can ask you dry density also. I will show you some other question for dry density. Tell me how much will be submerged density. Tell me in gram per centimeter cube. Everyone please comment. Extra, okay. Extra point we are discussing. How much will be gamma submerged? How much gram per centimeter cube? Everyone please comment. Very good, 0.5. How you are getting? Gamma submerged is equal to gamma saturated minus gamma W. Okay, gamma W is equal to 1 gram per centimeter cube. So gamma saturated we already calculated 1.5 gram per cc I'm telling. So 0.5. Understood? So like that they can ask you any question. Have that concept. Now one important thing I'm telling. Okay, let it be there. I will discuss that concept after some time through another question. Nothing but if they are giving some saline water or something. Understanding? By default, this is a fresh water. Water means it's a fresh water. Suppose it is suppose a sea water. They're telling something under a sea. Okay, saline water, or we have a soil and we are adding kerosene into that or some other solution. Then it is not water. It is not fresh water. If it is seawater or kerosene, then you cannot take simply 9.81 and all. You have to consider its specific gravity. I will tell you as a separate question. I will tell you some shortcut to do such question. Previous gate questions are available. Is it clear? Is it clear till now? Okay. Yeah, Kasturi Das, I will come to that through a question. Don't worry. Clear, guys? Now, can you do this question? Everyone? Don't think that we have solved only one question in half an hour. We have discussed that one question is equivalent to 100 question. Okay. I can ask you a lot of questions from that, and that is the foundation stone. If you have the foundation strong, then whatever superstructure you want to construct, you can do it easily. So properly read the question and understand what we have to do. Try to start solving it. After a few seconds, I will also start along with you. So I hope the first question was clear to you. Dilip, I think PPT is clear. Maybe you just try to increase the clarity of your YouTube that settings. 480, at least 480 you keep. I mean, I don't know during live whether you'll be able to do it or not. PPT is clear, right? The font size and everything. Should I increase the size? If anyone is watching in mobile phone. Yes, I don't know whether while live you will be able to increase the clarity. I think yes, no? Yes, quality you can increase during live also, no problem. So at least you put it for 80 or 720. Definitely you will be getting it. Okay, thank you for commenting. So started solving it. Are you getting the answer? What to do? Common data question. Nowadays they are not asking common data question. What I am trying to give you, any part of this can be the gate question. Okay, either the first question or the second question can be gate question. Okay. Yes. Thank you for commenting. Are you getting what? How much is shrinkage limit? What is shrinkage limit actually? I'm just showing another slide. Yes. Do you remember this figure? Volume versus water content graph. It's very important. I will explain this after some time. Still, I can tell you the shrinkage limit is nothing but, you might be already knowing this very basic thing. Shrinkage limit is nothing but, it is the minimum water content. Now, this one. The volume will remains the same till that point. Even if you are decreasing the water content, then the volume of soil is not going to get decreased. Remains the same, because once the value, I mean, once the water content is becoming the shrinkage limit, nothing but the minimum water content you require to make the soil 100% saturated. Okay. So if you are simply decreasing the water content again, still the dried volume remains the same. So that's why we are just drawing a horizontal line. If you are adding the water again, which means this is corresponds to 100% saturation. Okay, this is corresponds to 100% saturation. Now, if you are adding the water again, then obviously the volume is going to increase. That's why we are drawing something like this. See, every time it may not be exactly like this. Okay, some particular angle and all. We are just approximating it so that we can calculate the slope will remains the same, like that we are assuming. So if they are giving some particular water content, plastic limit, liquid limit, corresponding volume, they are asking some other volume, you can just equate the slope of that particular line is equal, and we can just calculate it. So this is nothing but the shrinkage limit. So I will tell you this after some time again. If I are coming back to our particular question, shrinkage limit is nothing but some water content it is. Okay, shrinkage limit is nothing but a water content. So we have so many equations to calculate the water content. What is that? Water content is nothing but, I'm putting WC. Okay, water content is weight of water divided by weight of solid. Either you can calculate using this equation, or we know E is equal to Wg by SR, degree of saturation, and our shrinkage limit is nothing but this W value. We know whenever this water content, I am putting shrinkage limit. Okay, I can put simply Ws or whatever. Then we know the corresponding degree of saturation I have to substitute. Can you please tell me what is the degree of saturation corresponds to shrinkage limit? I have already shown you that enough. So if I am putting instead of this W, if I am putting shrinkage limit, if I am representing Ws, then I have to put SR equal to 100% or 1. Yes, very good. Yes, very good, very good. Understood? So do you know what is E value here? No. Do you know what is specific gravity? Yes, 2.65. Specific gravity is given. So E is equal to shrinkage limit into 2.65 divided by 1. So if I can calculate the E value, then I can calculate the shrinkage limit. So can you try that? Very important. Just come back to this. Whenever they are giving something like oven dry, this is the hint. Whenever they are telling that it is oven dry, then whom should come into your mind? Oven dry means you have to think about the dry density. You have to think about the water content and all. Whenever you are seeing this word in the question, think about dry density, think about water content at dry state and all. See, you have a dry soil sample, means previously we have soil, in between you had water also and air also. Now once you are making it oven dry, the complete water is removing and you are getting only the dry part in the sense solid is there plus air is there. Okay, dry volume doesn't mean that only solid is there, air also will be there. Now what they are telling, dry volume is 300 centimeter cube and the weight is equal to 500 gram. What do you mean by weight in dry state? It is weight of solid plus weight of air. Okay, similarly this one, oven dry volume means volume of solid plus volume of air. This is something you have to remember, very important. But we know how much will be the weight of air. How much will be weight of air? 0. Very good. So at dry state, the weight is absolutely equal to that of weight of solid, but volume is not equal to that of solid. This is a point which most of the students used to make mistakes in the examination hall as well as in my classes. Okay, when I'm observing, even before telling this concept. Okay, dry state means volume of air is also there. Okay, very important. Now see, how can I calculate now? I told you, whenever they are giving you the oven dry, we know the equation of gamma D, that is equal to gamma W into G divided by 1 plus E. Those who don't know this equation, see gamma W, I have written the general equation in the first question where it is, see, gamma general equation, this was gamma bulk, okay, bulk density. So that this SR will become 0, saturation is becoming 0. So this second part is 0. So gamma W G divided by 1 plus V. We have a lot of equations I will tell you later. But gamma D, I also know what is the equation for gamma D. Weight of solid. Okay. Dry portion means it is completely solid. No? Weight of solid divided by volume of, tell me. Everyone please comment. Should I write here solid or should I write volume of soil? Tell me, which is correct? First one or second one? Everyone please comment. Is it solid or soil? Everyone, please comment. Soil, yeah, solid. Both answers I am getting. Now properly listen. That's what I told you. Most of the students used to make mistake. This is wrong. This is not gamma D. This is gamma S. Unit weight of solid. Okay. This is not gamma D. Gamma D means unit weight of soil at a dry state. I will show you one equation also. See, look at this equation. Very, very important. Majority of the students used to make mistake. Just look at the difference between gamma S and gamma D. Under gamma D, it is total volume of soil. Total volume means a dry state it is. Total volume means solid will be there. Air also will be there. Very, very important. Whereas in unit weight of solid, then that is completely solid only. That whatever we have seen, whatever we are able to see. Clear is it? Okay. Many students have commented solid also. Understood? Those who have commented solid, understand your mistake. Okay. This is one very simple mistake, but it's a very serious mistake. Understanding? Okay, we'll come to this slide. Come back to the question. Now gamma D function will be our gamma D. Weight of the solid given by 100 total volume solid soil. What is the total volume of soil? Can I take 300? Yes, 300 is not the total volume. Not only we are considering the sample means it is air also. Okay, is it clear, guys? Okay, 300 centimeter cube. I hope now the delay, I mean, there was a little bit internet issue, audio lag was there. Okay, I hope you are able to follow it. It's due to the internet issue from my side. I hope you have not missed any point. Okay, so that we know that we can simply, that how much we'll be getting 5 by 3, no? 5 by 3 gram per centimeter cube will be getting. That we can just equate to gamma W into G divided by 1 plus E. And gamma W we know 1 gram per centimeter cube. G value, they have given in the question G value 2.65. E value is unknown. Now we can easily calculate E value. Tell me how much is E value. Very good. 0.59. That's it. See, either you can put 5 by 3 to get accurate answer, or you can substitute 1.667 something it will be, no? 5 by 3 means 10 by 6, yeah. 1.667 you may be getting. Either you put 5 by 3, then you will be getting exact answer. Are you getting 0.59? E value 0.59. Hana? Yes, very good. Now go back and substitute here. Your answer is ready. 0.59 is equal to shrinkage limit into 2.65. So shrinkage limit is equal to 0.59 divided by, yes, very good, divided by 2.65. Your answer will be 0. Are you getting the same answer? Please comment. I want to check whether my calculation is correct or not. Clear, guys? Tell me, are you getting 22.26? Everyone? Yes, very good. Thank you. Okay, the first part is ready. So round off to 1 decimal. So you can put 22.2. Okay, as simple as that. Okay, or 22.3. Both are correct, no issue. They will give you a range, okay? Because here and all calculations are involved, no? 0.58. Some of you may be taking some 1.6 or 67 or 6667. So slight variation will come. So they will take care of that in the given answer key. Some 22.1 to 22.4 like that they may give. Okay, don't expect big ranges because simple calculation it is. If so many steps are there, they will give big ranges. Okay, don't worry. Right. Now first part is over now. Are you getting everyone? So I'm putting 22.2 as the answer. Clear, guys? So what we need to understand, whenever you are seeing shrinkage limit, you have to think about this equation Wg by S, where S is equal to 100% 1. Okay, that's what you have to think about whenever you are seeing shrinkage limit. If they are giving you plastic limit, liquid limit and all, then we can go in the other cases. I will explain something in the second question also. And whenever you are seeing oven dry, just think about this equation, gamma D. Always remember this, okay? Volume is air also, but weight, since it is 0, simply we are getting weight of solid. Clear? Now, that's nothing but one more thing I'm telling here, simply. This gamma S divided by gamma W is nothing but your, tell me, what is this? Gamma S divided by gamma W is what? Everyone please comment. Gamma S divided by gamma W is yes, very good. Nothing but your specific gravity of solid. Okay, whatever 2.65 something we have written up, that's it. So in this particular question, why I told that, suppose in this question, if they are asking you how much is the volume of solid, okay, separately if they are asking, then what you can do? Then use that concept, gamma S concept you can use. G is available, then properly equate it, you will be finally able to get it. Clear guys? Okay, by mistake don't take gamma S here. Clear everyone? Gamma S by gamma W equal to G. That's it. Now coming back to the second part. What will be the water content at which the volume of soil sample get increased by 20% of its initial dry volume? Getting complicated? Very simple it is. Whenever you are seeing, see, these are the repeated type of questions, okay? Whenever they are asking, they are giving some particular increase in volume. They are asking you the corresponding water content or change in water content, whatever. Whenever they are asking some water content and increase in volume or change in water content and increase in volume or decrease in volume, you just have to do what you have to do. Just you have to think about this particular graph, where it is this particular graph. We have an equation, we have a lot of equations for shrinkage limit and shrinkage ratio. Some very, very important equation I'm just writing here. 1 second. Yes. Whenever you are seeing questions related to the change in volume and change in water content, always remember about shrinkage ratio. Nothing but any water content, sorry, any volume. 1 second. Yeah. Any volume V1 and its volume is changing to V2. Okay. Any volume V1, its value is changing to V2. Okay. Divided by the dry volume. What do you mean by dry volume? Nothing but, that's why I told you to remember the graph. See this one. Okay. That is the least volume, dry state. Now, where it is our question? 1 second. Yes. Remember, V1 minus V2 divided by VD whole divided by the corresponding water content of this V1 minus the corresponding water content of second volume. That's it. Very easy to remember. Generally, shrinkage ratio is a complicated equation for many students. Don't get confused. V1 minus V2 divided by dry volume. This is the only constant part here. Okay, shrinkage ratio. Somewhat related to shrinkage now, WVD. Okay. Now, if they are asking, now we can equate it to anything. Now, simply, if I'm equating to, if for example, if I'm taking, I want to take shrinkage limit into this equation, what I can do? If I want to use shrinkage limit value into this equation, what I can do? Either you can substitute W1 equal to shrinkage limit, then V1 will become, tell me, if water content is equal to shrinkage limit, what will be the volume? What will be the volume? Obviously, VD, we have already seen in that figure. So if you are substituting W1 as shrinkage limit, corresponding V1 you have to put it as VD. If you are putting W2 as shrinkage limit, corresponding V2 you have to put it as VD. That's all. In the sense, I can also write it as shrinkage limit is equal to, for example, if I am putting V2 as shrinkage limit, V1 minus VD. V2 corresponds to shrinkage limit. Denominator is always same VD. What is changing? Corresponding water content will become shrinkage limit. Are you understanding the equation of shrinkage ratio? It is a complicated portion for many of the students, but it's very easy actually. Is it clear? Yes. Now what they are asking, if there is an increase in volume of 20% of its initial dry volume. Initial dry volume is, let it be VD. Final volume is increasing by 20%. Now what will be the new volume? What will be the new volume? Initial volume is VD, dry volume. If it is increasing by, yes, 1.2, that's it. And new volume is becoming 1.2 VD. 20% increasing, correct. Yes, 360, very good. This is given as 300 centimeter cube in the question, dry volume. Now this is becoming 360 centimeter cube. Okay. Now I can put this V1 is equal to 360 centimeter cube. VD is equal to 300 centimeter cube divided by 300 centimeter cube. Actually, no need to calculate that 360 also. Whenever they are telling it is increasing by 20%, obviously this part is going to be 0.2. And now, see 1.2 VD minus VD, 0.2 VD. So, yeah, divide by VD will become 0.2. And now, corresponding water content is W1 minus corresponding shrinkage limit. Now, we are putting second volume as VD. How much will be shrinkage limit? We already calculated 22.62. So either we can put it in percentage or in decimal. Correspondingly, we have to change everything. So convert into decimal for calculation simplicity. 6 now. Sorry. Now everyone calculate. Okay. So we don't know what is shrinkage ratio, right? Are you getting this correct? Okay. Now very important. Remember this another equation for shrinkage ratio, gamma D divided by gamma W, as simple as that. Okay, shrinkage ratio is nothing but gamma D divided by gamma W. How much is gamma D divided by gamma W? Yes, very good, very good. How much is gamma D divided by gamma W? We have already seen gamma D, 1.667 something. Okay, simply I can put 5/3 if required, centimeter cube. Gamma W, then in the same unit I have 1. Clear? 1.667, whatever. That we got it as this numerator part is 0.2 divided by, see, unitless it is, okay? Centimeter cube will get cancels. W1 minus 0.2226. That's it. Now we are getting the corresponding value of water content. Everyone please tell me how much you are getting. Very good, Balakrishna. 34.3, absolutely fantastic. 0.3426. I can put it in percentage. Okay, approximately 34.3%. Very good, very good. Are you getting the right answer, everyone? We have to report in percentage round off to 1 decimal. So 34.2 or 34.3, whatever. Are you getting the answer, everyone? Okay, now whenever you are seeing, see what is more important for us, how to approach a question. Whenever you are seeing some increase in volume or increase in water content, they are asking the corresponding volume or corresponding water content. The thing you have to remember is this shrinkage ratio and just try to compare with that. It's very easy to do it. Clear, guys? Okay. Naresh, have you joined just now only, or if yes, then later you will be getting this video. That time you can just watch it, no problem. Okay, because if I'm again going back and explaining all these things, it may take time and others may get bored. Okay, you can just watch it later, no problem. Always remember, simply you remember one thing, whenever they are asking, see in this question you just check, they are telling some increase in volume 20%, then corresponding water content and all we have to see. Okay, so as water content changes, corresponding volume also we can take, then corresponding we can simply equate in the shrinkage ratio equation. In shrinkage ratio equation, this part is always constant. Okay, shrinkage ratio and VD we are keeping it there. Now whatever value you can substitute for V1 and V2, no problem. Corresponding water content you have to substitute as W1, W2. That's all. Okay, if you are putting any V1 or V2 equal to dry volume, then corresponding water content you have to put WS. Similarly, you can do in the other way also. W1 you can put WS, but correspondingly the volume also you have to put. That's all. Is it clear? Okay, what are following? Yes, clear, guys? Now I have already shown you that part. 1 second. Yes, this equation I have already shown you. Very important. Don't mistake among these two. This is what I have observed. Many students are making mistake for gamma D equation. Instead of taking volume of soil, They are taking volume of solid. Don't do that mistake. Now see the gamma dry equation we are getting gamma W into G divided by 1 plus E. Okay, I guess there is some voice lag is coming. Sorry for that. I hope you are not missing any data, missing any explanation. Now that equation is also known as equation of zero air void line or 100% saturation line. Both are equal. Equation of zero air void line, equation of 100% saturation line, both are same. What is that equation? Nothing but this one. Gamma W into G divided by 1 plus E. So why we are actually zero air void line? This NA stands for percentage air voids. This NA stands for percentage air voids. If there is no air void, then we are going to get the equation. If percentage air void is 0, okay. If percentage air void is 0, then this equation will become this. Okay. So also we know simply, if I'm simply writing a general equation, gamma W into G divided by 1 plus, can we write E is equal to WG by SR? In general sense, WG by SR hypothetical condition. Okay, in simply. Now you see, in this WG by SR, okay, nothing but E only. In this WG by SR, if I'm taking this 100% saturation, yes, we are getting equal to 1, na? Yes, we are getting equal to 1. So there is no change happening in the equation. That's why 100% saturation and zero air void line is taking as same. Don't think that, see, suppose if I'm telling 10% air void line, 10% air void line and 90% saturation line, is that equal or different? Everyone please comment whether this itself can be an MCQ question. Okay, can you tell me? Can you tell me 10% air void line and 90% saturation line, is that equal? Is that equal? I told you 0% zero air void line and 100% saturation line are same. Okay, concept it is it very good? This is different. Okay, because if I'm putting a 0.1 and if I'm putting 0.9, are you getting same? Obviously no. Okay, because it is 1 plus and all. It is completely different. If this 1 plus was not there, then equation is getting same. Okay, so remember these are different. This concept is only for zero air void line and 100% saturation line. Simply that is for 1 mark purpose. They can ask you, okay, which of the following statements are true? There they can use this concept. Okay, simply remember. Now I'm just showing you some important relationship which you can use in the numericals. Very, very important relationship. Gamma D is equal to gamma divided by 1 plus W. If they are giving any value of bulk density, this gamma stands for bulk, okay? This bulk density can be anything actually. Whatever be the water content, corresponding water content, if you are substituting, you are going to get dry unit weight. It is very, very important equation. They can give in some question the bulk unit weight. Sometimes they will give weight of soil. What is this gamma bulk means? Weight of soil divided by volume of soil. Okay, it is not solid and all. Total weight of soil divided by volume of soil. They can give in the question a soil sample is having this much volume and the weight is this much. They can tell the water content is this much. If they're asking what is the maybe void ratio, how can we calculate? From here we can calculate gamma D. Then using the equation gamma W into G divided by 1 plus E. They may be giving you the G value in the question. From there we can calculate E value. Understanding? So like that we can do the question, even if they are not giving you the degree of saturation. Clear guys? Clear guys? Okay? Yeah. Adnan, understood now everything? Now that is very important point. Now see, from there I can derive one more equation. This is actually, I'm deriving from it. Gamma D is equal to gamma bulk divided by 1 plus W. Then weight of solid will be equal to bulk weight of soil, the complete weight of soil divided by 1 plus W. We can prove that actually. I'm not showing you the proof and very, very easy. Okay. Simply if I am drawing if I'm showing you what is gamma D equation, weight of solid divided by volume of soil. And simply if I'm writing that, gamma D is equal to, I'm just rubbing this portion. What is gamma D? Weight of solid divided by volume of soil. Now what is this gamma bulk? Weight of soil divided by volume of soil, divided by 1 plus W. It will come like this. Correct now? Now you see this volume of soil will cancels. Very simple. Then you are going to get this equation. Weight of solid is equal to total weight divided by 1 plus W. This is very, very important. It will help you like anything in doing the questions, numericals. If you don't know the shortcut, then also you can solve it, but you will take some more time. That's all. More in the sense, maybe some 20 seconds you may take extra, or maybe you may make some mistake because we have to substitute the corresponding degree of saturation sometimes. So in case if such questions are coming, if they are giving you the total weight of soil and the water content is also available, somewhere if they are asking you the weight of solid part, then no need to do some other calculation. You can directly use this particular shortcut and do it. That's it. If you are forgetting also, no problem. You will get some more time. That's all. Okay. Is it clear, guys, till now? Similarly, you can remember this equation also. Vs is equal to V divided by 1 plus E. This is also very important. Volume of, see, this is weight. If it is weight, then we are using water content. If it is volume, then we are using void ratio. So don't get interchanged and make mistake. So volume of solid, if they are giving some complete part of soil, a soil is there. Soil will be having solid, soil will be having air, it will be having water also. If they are asking what is this portion out of this total portion, and they are giving you what is the void ratio, easily we can calculate this total volume divided by 1 plus E. Then we are going to get what is that solid portion. Clear, guys? We can prove it. We don't have to prove and waste our time. Understood? Understood? So here it is water content, but whenever it comes to volume, it is void ratio. Clear? Ankit, clear? Water content will come corresponds to weight, volume will come corresponds to, void ratio will come corresponds to volume. Okay, this Vs part will be always a constant. If you are whatever we are doing, if you are adding more water or whatever, volume of solid will remains constant always. If you are compacting or whatever, volume of solid will remains constant, but volume of soil will change. Clear now? Yes, remember those portion, and you can just remember this one also can be asked for 1 mark purposes. Your gamma S, nothing but unit weight of solid. S stands for solid, not soil. Okay, soil means we just used to write bulk, or sometimes we'll simply represent gamma. Simply by default, gamma means gamma bulk, or weight of soil divided by total volume of soil. This is total. Okay, everything total. Sometimes we'll put simply gamma or gamma bulk. Okay, by default. This is gamma solid, obviously greater than gamma saturated. So this equation you simply remember. Okay, always gamma S value will be highest. That will be a particular constant value also. Clear, guys? So these many points you simply remember. These are the basics. Okay, these are the foundation stone. If you are making these things very strong, then whatever question they are asking, so many gate question you can easily solve if you have the concept. Okay, you can just make equation in the examination hall itself. Understanding? Now that's it. Now I was just showing you this one. Later I can show you this graph also. Just keep this in mind. Okay, I can show you later. Now, yes, can you 1 second? Yes, just look at this question. This concept will help you a lot. Once they ask the question somewhat similar to this, for many competitive exams, important numerical question they are asking from this particular concept. Very easy. Now you should solve it first. If you don't know the shortcuts, which I have just shown you, If you don't know that, then you will take time. You may require some 2 minutes or 3 minutes to solve. You can solve, no problem. If you have the concept, you can solve it within 3 minutes or 4 minutes, no problem. But if you know that concept shortcut, then you can just save a lot of time. That is the advantage of remembering those equations. Okay, Vs equal to V by 1 plus E, Ws equal to W divided by 1 plus W, those things. So are you able to proceed? That's what you have to look first. After some time, I will explain. Please check the question and understand what to do. You might have already noticed the question, right? Site X, site Y, site Z, like that they asked a question. They asked again, I guess. 2 years they have asked. In many papers I have seen, apart from GATE exam, in many places I have seen the questions like this question as well as related to cost and all. And in many other questions will come using this particular concept. Yes, which equation are you going to use? Everyone please comment which equation you are going to use. Are you going to use any shortcut or are you going to solve like anything like university exams? Shortcut, okay. Which shortcut you are going to use? If I'm just showing the previous slide, please tell me, are you going to use the, let it be, this is the first equation, this is the second equation, this is the third equation. Tell me 1, 2 or 3. Which equation you are going to use? Yes, very good, very good, very good. I'm already getting the reply even before asking. Good, very good. Which equation you are going to use? Very good. The third equation we are going to use. See, any equation you can use, by the way, but the length of the solution will be little bit changing. Okay, that's all. Okay, very good. So whenever you are seeing the questions related to, see, we have already seen volume and water content type of question. Volume changing, water content changing, then what to do? We have to think about the shrinkage ratio. That is the approach. You should have that concept. If you are solving some questions which I am giving and going back, no use. Just have the concept how to approach a question by sitting in the examination hall. That's what you have to acquire from this particular session. And that's what I'm trying to do also. Okay. Otherwise, if you're simply solving a lot of questions, then there is no use. You will get a lot of questions in some other books also. No need to attend the session. So as we have already discussed, whenever you are seeing different water contents, corresponding volume, think about shrinkage ratio. Whenever you are seeing different void ratio and different volume and water content, think about shrinkage ratio. Volume and void ratio, think about that particular third equation. Vs equal to V divided by 1 plus E. Think about that. So what we have to see? We know volume of solid is equal to volume of total soil divided by 1 plus E. We have already seen that. Now see, I told you, whatever you are doing, your volume of solid will remain same. Volume of solid will remain same. But if you are compacting, volume of air may get decreased and all, volume of it will compress, total volume will decrease, but as the E value may change, but volume of solid will remain same. So if this value will remain same, can I write simply V stands for total volume of soil. Can I write V1 divided by 1 plus E1 is equal to V2 divided by 1 plus E2 is equal to V3 divided by 1 plus E3, etc. Can I write like that? Can I write like that? Okay. Then what you are not understanding? Okay, आवाज नहीं आ रहा है. Okay, sorry. I thought you are not understanding anything. Is it fine now? Is it fine now? Okay. Maybe try to increase the volume of your system, or if it is from my side, I'm sorry. I'm helpless. I'll try to increase the volume, don't worry. So are you understanding this one? V1 divided by 1 plus E1 will be always a constant. V stands for volume of that particular soil. This V includes solid plus water plus air. You know, it includes this everything. So solid plus water plus air divided by 1 plus E remains the same. Okay. Now, if we are going back to this particular question, what they are asking, we have some particular volume, nothing but 60 meter cube, sorry, 60,000 meter cube we have to make. You know, how we have to make that 60 meter cube of volume? 60,000 meter cube of volume we have to make with a void ratio 0.8. How can we make? Either we can make by taking from the supplier P and put it there, or we can do it by taking from supplier Q and put it there, or we can take from supplier R and put it there, or we can take it from supplier S and put it there. Okay, so we have to check purchasing from which supplier that is more economical. So what we need to do, we just have to check the cost. But how can we check the cost? They told the cost here 7 rupees per meter cube. So if I am getting the volume corresponds to PQRS, I can multiply with the corresponding rate. I will be getting the maximum value, I will be getting the minimum value, and so on. Correct now? Correct now? Yes, very good. I'm already getting the answer. Fantastic. Henna? So our task is what? Calculate the volume of soil which we are purchasing from P. Calculate the volume we are going to purchase from Q. Calculate the volume of soil that we are going to purchase from R, and similar S. How can we calculate? How can we calculate what is common in between these two? Here also we have so much of soil. Here also soil. Here also soil. Here also soil. What is common? What is common between? If you are taking something from somewhere, putting another somewhere, what is common here, everyone? If I am taking some soil from some particular place, putting the same soil and some other place, whether I'm compacting, whether I'm not compacting, whatever, what is common here? Very good. Volume of solid. Getting volume of solid remains the same. That is what you have to remember. If I want to fill this 60 meter cube, maybe I may have to take more soil than put and then compact and all. You know, sometimes I just have to put some little bit soil. If I'm having more void space and all, it depends. But what is equal? Volume of solid will be always equal. Now what we can do? We have the total volume here. We have the E value here. We can just equate with the volume that we are going to purchasing from P divided by 1 plus E corresponds to P. As simple as that. Similarly, V of Q, 1 plus void ratio of Q we can substitute. Similarly, the volume that we are going to purchase from R divided by 1 plus E of R, V of S divided by 1 plus E of S. As simple as that. EP, EQ, ER, ES is given in the question. This left hand side V is 60,000 meter cube. This E is 0.8. Everything we have. Substitute with the P, substitute with the Q, substitute with R, substitute with S. We are going to get the value of VP. We are going to get the value of VQ. We are going to get the value of VR. We are going to get the value of VS. Now what we have to do? Everything we are getting in meter cube. They have given some rate, 7 rupees, 6 rupee, 8 rupee, 10 rupee. Just multiply with the corresponding rate. Just multiply with the corresponding rate. Sorry, how much it was? 7, 6, 8, 10. So do it and tell me which is more economical. Tell me which one is more economical. Yes, very good. Always. Everyone tell me. Take your time. No need to be very hurry. I'm not writing everything. VP, are you getting 63,333.333 something? Henna? VP value, not the multiplied rate value I'm telling. VP, are you getting 63,333.33 something? Yes, whatever it is, you just calculate, put it there. Then the next one, you are getting 76.8 sorry, 76, 66 point something like that you're getting. Calculate it, put it there. Are you getting VR as 46,000? Something like this. Put it there. VS I'm getting something around 50,000. Put it there. Which is the least value, guys? Very good. Q, is it? According to my calculation, it is not Q. Niru, can you please check your calculation again? Everyone. Which one you are getting as most economical? I am getting as R, which is around 373, 333 something. Yes, very good. Thank you, Sumitra, for commenting. Are you getting the same answer? 373, 333 point something. We don't require the value, okay? We just have to compare. Yes, everyone is getting the same? The least value will be the most economical, obviously. R, yes, very good. Thank you, Naresh. Very good. Balakrishna is also getting same answer. Very good. Hena, understood? So, which is our correct answer here? Option? That's it. Okay. So, simply by looking at this, don't simply guess it. Okay. We have to check the corresponding void ratio also. Okay. Very, very important. Yes, approximately 373, 333. Yes, very good. Nero is also getting Gursaj. Very good. Ankit, very good. Understood? So answer C will be the right answer. Now, are you getting the confidence like how to proceed when you are seeing a question? Okay, rather than simply solving a lot of questions. Even if you are solving only less number of questions, take the input from that. Okay, what you are going to do in the examination hall when you are seeing a fresh question, they are not going to ask you the same question. Something from this you have to catch and apply in the examination hall. Okay, right. Are you following, everyone? Are you getting the benefit from the video? Please comment, everyone. Are you getting something? At least something? Yes, thank you. Thank you so much. Now, one small concept, but an important concept, relative density. Not doing any question. Just understand what is relative density, also known as density index. If they are asking, they can ask you directly. Or why you have to remember this? We have seen a lot of questions, in gamma saturated or in many places we have to use this void ratio E. Many places, density equations, or in many other, we are going to solve a lot of questions. Wherever we require the value of E, either they can give you the porosity value N, then using this N value, we can calculate E. And we have already seen. Or what they can do, they can give this relative density in the question. So that they will also give you what is the maximum void ratio possible. They will also give you what may be the minimum void ratio. Maximum void ratio is nothing but the void ratio in its densest state. Minimum void ratio means in its loosest state. Understanding? If you are compounding it more, then opposite, na? Volume of void, 1 second. Volume of void divided by, yes, correct. Okay. So they can give that also. From that, you can just calculate what is the value of, opposite, na? Loosest state, you are going to get maximum. Yes, this is completely opposite. Sorry. Void will be more in loosest state, na? So this is loosest state. This is densest state. Right? Now see, either they can give like that, E max and E minimum, or they can give in the loosest state this much, in the densest state this much. They can give you the ID value, which is the relative density, from where you have to calculate the E value and substitute in our gamma saturated equation or gamma submerged equation, wherever. Understanding? Clear? Yes, the same thing you can do. Yes, very good. The same thing you can, yes, thank you, Naresh Chauhan. The same equation we can also write it as gamma D equal to E max 1 by gamma D minimum. Okay, opposite, na? Void ratio and density. is getting densified means void ratio will become minimum, opposite. So 1 by, so divide by whatever is the gamma value we are getting, divided by 1 divided by gamma d minimum divided by 1 by gamma d maximum, opposite to that of this E value. Maximum will come as minimum, minimum will come as maximum, like that. So they can give in any form, so that this equation we may not be able to directly use for E. We have to calculate ID value, and or if they are giving ID value, we can use this equation for taking that or extracting that void ratio, substituting in our solution. Okay. Or one application of this, if you are using spherical shape, see like this. Exactly, if you have spherical shape of solid particles, the loosest packing will be something like this. The loosest packing will be if I'm exactly placing one above the other. See, same size and same shape, exactly spherical, rounded particle. This is the loosest one, loosest packing. It is found that for a loosest packing of a spherical shape, do you remember? Do you know what is this value? It is found as a constant value for the loosest. This is a spherical shape, okay, or rounded particle. Not for angular particle, not in a general case, just for that particular shape only, okay, only a special case. Yes, very good. E will be always 0.91 or 91%. Some materials or textbooks used to take 0.9, as simple as that, almost same, okay. 0.91 is more accurate. If you are making it densest form for the same spherical and rounded, if you are making it densest, how can we make it actually? If we have some particles like this, in that gap we have to put in between two. So this is how we can closely pack it, densest form. Okay, this is the densest form. Then do you remember what is this E value? Very good, 0.35 or 35%. Sorry, 0.35 or 35%. This is only a special case, only for this one. Okay, it's not general case. Generally, we'll be having some angular particle. E can be, what is the range of E? Yes, that itself can be a gate question. What is the range of E in general? Is it whether E max is equal? Okay, tell me what is E minimum? E minimum, can it be negative? Is it negative or is it 0 or it is a positive value? Is it a 0? Can it be negative? Obviously no, it's a numerator, it's a void, no? Volume of void divided by volume of solid. Can it be 0? If volume of void is 0, it can be 0. Practically, no. Theoretically, we can tell it is, yes, it can be 0, but practically E cannot be 0 because we cannot make 100% compaction. Definitely there will be a slight void. Okay, so E cannot be equal to 0 also. Definitely it will be somewhat more than that. So it's going to be a positive value. We generally used to write like this. You know? 0 not included. If 0 is included, we'll put a square bracket. What can be the maximum? What can be the maximum value? Is it 1 or else can it be more than 1? Is it 1 or more than 1? That itself can be a gate question. Yes, very good, Naresh, you are correct. Yes, very good. There is no maximal limit. Nothing like 1. This volume of void can be more than volume of solid also. If I'm taking a very large, for example, just remember a sponge. Sponge is having so much of solid portion. Lot of void portion is also there, no? So like that, if you are taking a very loose soil, void space may be more than volume of solid. So it can be more than 1. So we just used to write the range of void ratio as 0 to infinity. Okay, it can be anything. We don't know what is the maximum limit. So no limit. Whereas for N value, porosity, tell me what is the minimum value of porosity? Volume of void divided by total volume. Yes, very good. Tell me what is the minimum value of porosity and what is the maximum value of porosity? Everyone? Everyone? Yes, very good. This also not possible exactly 0, which means the volume of void cannot be 0. Okay, similar to void ratio only, but maximum value will be always 1. Okay, we can simply put it as 0, 1, but 1 is included. So like this we'll put square bracket when it is including, open bracket when it is not including. Okay, because as volume of void keep on increases, total volume is also increasing because this VV is present in this V total also. है ना? Understood? So these things can be asked for 1 mark. Similarly, degree of saturation. That you tell me. Degree of saturation, what is the, sorry, this is not E. I've made mistake here. N, okay. What is the value of degree of saturation, minimum and maximum? Volume of water divided by volume of void. Yes, very good. It can be 0. Maximum value is 1. If there is no water at all in the soil, complete void is air. Then complete void is air means it is equal to 0. If complete void is water, there is no air at all, then maximum value 1. Okay, nothing but our 100% saturation state. So how can we write it as square bracket 0, 1. Okay, not open bracket, square bracket, both side. Understanding? Clear, guys? Okay. Similarly, you can do air content also. Very good. Air content is what? Volume of air divided by volume of water. Exactly opposite. Air content plus degree of saturation will be always 1. How much is air plus how much is water? It's nothing but your volume. So this also we can put 0 to 1. Okay, see, these are the basics. Clear, guys? Okay. Yes, similar to water content also. Yes, water content, very good. Water content will be if the weight of water, if there is no water, then 0. Weight of water can be anything similar to this E minimum and all. E minimum and E maximum. Water content is also having no limit. It can be more than 1. Very good. Okay, for 1 second. Okay, here. Yes, it cannot be closed bracket. Yes, very good. It will be open bracket only. And avoid porosity. Because when it is going to be 1, very good point. Who told that? Ali Munshi? Yes, very good. See, whenever it is open bracket, it means what? It is equal to 1. How I have to write? Okay, maximum value is 1, but it will not be 1. 1 is not included. Okay, I can put like that, something less than 1, like that I can put. Because whenever volume of void is becoming volume, total volume, what is the meaning? There is no soil, complete, see, like this air, complete air. It's not a soil. Yes, very good. By mistake I put that. Thank you for noting that. Understood? Okay, so shall we go to the next question? See, don't simply look at the number of questions that we are solving. We are discussing so many concepts, okay? These many concepts are equivalent to some 100 questions. So take this next one. Through the questions, I'm just revising geotech. Okay, so do this question. We'll continue this session for half an hour more. First session, okay? You will be getting second session, third session in the coming days. If anyone have joined late, the second session will be day after tomorrow, same timing, 2:30 to 4:30. And the third session, that will be our final one. So you should watch all the session, okay? Then only you will be getting that confidence. So do it fast. Try to understand it. properly read the question and understand what we have to do. Obviously, it's going to be more than one options will be correct because they are giving different things in the options. So more than one can be, okay, may be correct. What is your problem? Properly check it. How much will be the plasticity index? Remember the equation of plasticity index. What is the equation of toughness index? Yes, very good. Properly check it. What is the answer and all? Very, very important concept. What is plasticity index? What is toughness index? Yes, let me check for the answer. I'm already getting the reply. Let me check your answer is correct or not. Are you getting A as wrong? Plasticity index. Okay, A as wrong. Okay, fine. One second, guys. One second. Can you do one thing? I'm sorry. There is a typing mistake. Can you just make it as 20%? Okay, please make it as 20%. Okay, because nothing. If it is 28, also no problem. But I just want to compare with my answers. That's why. Okay. I have calculated and I have put these options based on 20%. But while typing there, I made that mistake. Okay. So make it 20% and proceed and tell me whether it is correct or not. Flow index formula, yes, there is a trick. There is a shortcut. There is a direct equation for flow index. Okay, toughness index. Okay, you want to know what is flow index. Okay, that I will tell you. Don't worry. Flow index is very easy. They may not be asking questions based on flow index, I guess, but I can tell you. Yes, now A is correct. I will tell after some time. Okay, Ankit. A is correct. Okay. So what is plasticity index? Very easy. Plasticity index is equal to WL minus WP. I have shown you this one. We were having a figure here. Yes. The difference between WL and WP is nothing but your plasticity index. We are just used to represent using IP, plasticity index. See, nothing but your liquid limit is nothing but if you are using Casagrande apparatus or it is somewhat related to flow index also. We will be getting a graph. So you can just listen here. Those who don't know, or those who cannot remember flow index. If you can take the water content on y-axis and number of blows on the x-axis. Okay, number of blows that we are using see in Casagrande apparatus, we are taking that apparatus and putting a gap between the soil and we are just rotating it. How many rotations we are making, that we will check, and whenever it is closing, whenever it is closing, we'll check that number of application and all, number of blows and all. So finally, we will be getting a graph something like that. We'll take this in log scale. So the flow index is nothing but any value if you are taking. Suppose if you are taking this particular value as W1, corresponding value is suppose N1. And if you are taking another value W2, lesser value, as water content decreases, obviously you have to give more blows to keep that gap together because it may be stiff that time, no? N2. So flow index is nothing but W2 minus W1 or simply W1 minus W2, higher minus lower, like that you can remember. W1 minus W2 divided by log N2 minus log N1. As simple as that. That is nothing but your flow index. And the value corresponds to 25 number of blows. We call it as liquid limit. This is nothing but your liquid limit. Okay. Value corresponds to 25 number of blows. That itself can be one more question. Okay. Now suppose, one more thing I am telling. What is WP? It is the minimum water content you require for a particular soil, so that you can take a soil sample and just do like this. So after scribbling, you will be getting a narrow like wire type without crumbling it, without breaking it. So that particular value, the minimum water content, we call it as, if the water content is lesser than WP, then definitely that will break, that wire will break. So that particular water content, we call it as plastic limit. Sometimes for some particular soil, liquid limit may be lesser than that of plastic limit. If you are solving, if you are doing the experiment, in case if you are getting plastic limit as greater than the liquid limit, in some special case, then how much will be your IP value? For example, if I'm telling, W plastic limit is maybe 20%, liquid limit is 18%. How much is your IP value? Can you tell me? Yes, for plastic limit, we are making that thread as 3 mm diameter. Yes, you're correct, Naresh. Can you tell me how much will be IP value for this particular example which I have written now? Is it -2 or is it +2? Very good. It is not -2. It is not +2 also. It is equal to 0. Yes, very good. Very good. Jayan, very good. Sumitra, Krishna, very good. If in the worst case, in some special case, if you are getting WP as higher, 99.99% of cases will be getting WL as higher only. In case if you are getting something different, okay, it is not minus, it is not plus, we'll take it as 0. Similarly, in hydrology irrigation, we studied, if you are getting runoff value as negative, we'll report it as 0. We have discussed that in our hydrology and irrigation session. So similar to something, okay, concept is different, but something like that you can remember. We are reporting it as 0. Okay. Similarly, this is plasticity index. We can just define consistency index, toughness index, a lot of things. In this particular question, they are asking toughness index, right? So how can we, which was the question? One second. Yes. This got 18%. Okay, option A is correct. So toughness index is nothing but flow index divided by IP value, as simple as that. So how much is the given value? Sorry. Plasticity index, sorry, opposite, I'm sorry. Plasticity index, we calculated already. Divided by flow index. So plasticity index is 18%. Flow index is how much? 0.1. Sorry, 0.9. Then how much it will be? Please everyone calculate and tell me. 1 second. Yes, are you getting 20? Yes, thank you. Okay, this 18 we are substituting in percentage so that we are getting in percentage. So what they are telling, if the flow index of the soil is 0.9, toughness index will be 0.1. So this is, I can write it as 0.2 also. If I am substituting IP in terms of, so that is wrong, no? They are telling it is 0.1, but it is 20%, 0.2. So that is wrong. Soil can be classified as GM or soil can be classified as SC. Sometimes one option may be correct or sometimes both can be wrong. Definitely both will not be correct. Only one. So how can we check which type of soil it is? The first thing we have to check is we should know whether it is a fine-grained soil or coarse-grained soil. Which means if it is a fine-grained soil, it can be either silt or it can be clay. Or if it is a coarse-grained soil, it can be sand or it can be gravel. And also if it is a coarse-grained soil, sand or gravel, it can be either uniformly graded or well graded or some sandy, some silty particles may present. So silty fines are more or less, we can compare and check whether this particular sand or gravel is silty gravel or clay gravel or silty sand or clay sand, like that. Little bit complicated portion when it comes to coarse grained soil classification. You have to properly study it. Okay. Or right now I don't have detailed question. If you want, you can just comment at the end of the session. Once this video is getting uploaded in the channel, you can just comment there. I can take a question and solve for some other type of soil also. Okay. In case if you're feeling difficulty in understanding that. So first of all, what we need to do, if they are asking, sometimes they will directly give what is the percentage fraction passing through each sieve and all, or they can simply give the weight retained. So that we have to remember our sieve analysis. What we require is how much percentage is passing through each sieve and a percentage finer value. That's what we need. So from there only we will understand how much portion is sand, how much portion is clay, how much portion is silt and all. Okay. So what we need to do from the given table, if they are giving percentage finer, then directly we can calculate. If they are giving something else, weight retained or cumulative weight retained or percentage weight retained, whatever, finally we have to obtain percentage finer. Okay, in between they can give any table. Okay, that's how you have to approach the question. Anything they can give. So if they are giving weight retained, simply only two things they have given: 4.75, 0.075 means 75 micron. How can we calculate the percentage finer from weight retained? What do you mean by percentage finer? How much total quantity has passed through it? You know? So the sieve size is 4.75 mm. We have 30 gram is retained and 0.075 mm. They have given that 830 gram is retained. Okay. If 30 gram is retained, how much will be passing? See, simply total is 1000 now. What they have given in the question? Total 1000 gram. What is the meaning of this? 30 is retained on 830, remaining 830 is retained. Totally it is 860. 30 and 830, right? Yes. Then how much will be in the collector portion? 30 and 800. Huh? Okay, sorry. 30 and 800. I was writing the cumulative value, that's why. Now, which means in the collector, in the bottommost plate, how much will be having? Yes, 170 gram. Okay, not required. Simply I'm keeping it there. Okay, just for understanding. Then we are getting total. Okay, retained. What is the cumulative value then? This is how we are going to find the percentage finer table. Cumulative value will be 30 gram. 30 plus 800. That is going to be 830. 830 plus 170. We are getting 1000 gram. Yes, completed. Now what we need to do? We need percentage finer. So what we have to calculate is percentage cumulative value which is retained. It means 30 by 1000 into 100. How much is 30 by 1000 into 100? Percentage, right? Similarly, this will be 83%, 100%. We don't require this third row actually. Okay, we require till second row only. Now, how much will be percentage finer? 100% minus, definitely. See, I have written this final one just for a check. Finally, you should be getting 100%. Okay. If more sieves are there, better check it. Okay, till end. So that is going to be 97%. This is 17%. Okay, this is obviously 0. Understanding? So what is the meaning of this? 97% of the total soil is passing through 4.75 mm. What is the importance of 4.75 mm? What is the importance of 4.75 mm? 170 gram is not understood. No issue. That is not required actually. Totally how much we have? 1000 gram now. Total 1000 gram we have. We took a sieve of 4.75 and below that we took another sieve of 75 micron, 0.75 mm. Then we will be having a collector also now. Below that, a collecting plate. So they are told that 30 grams retained here. Then some soil has retained here when we are passing 1000 gram. 30 retained here, 800 retained here means what? The remaining 170 might have came and collected here, no? That's what. Understood? Gursaj, understood? Not required to write, but simply I have written just for clarification. Clear? What is the meaning of this? Okay, tell me what is the importance of 4.75? If a soil is completely passing through 4.75, what can I call 4.75? The portion which is lesser than 4.75 mm. What we can call it as? What we can call it as? Can I call it as sand simply? No. If something is lesser than, can I? Everyone please comment. If a soil is passing through 4.75, I cannot simply call it as sand. It can be sand, it can be silt, it can be clay also. Yes, very good. And now, if it is clay, then also it will completely pass. If it is less than 4.75 mm, okay, not meter. Understanding, guys? Understanding? And till 75 micron. Till 75 micron, we call it as, understanding? Yes, till 75 micron, we call it as sand. In between, we can divide into fine sand, 0.425 mm, I guess. Fine sand, coarse sand, medium sand, like that, we can just classify. Then till 2 micron, it is silt. Then less than that, we can call it as clay. This is how we used to divide. Okay, this itself I told you we can just classify into fine sand. Like generally fine sand will be from 0.425 mm, and I forgot actually. I think it is 2 mm or 4.425 mm or something. Okay, you can just refer it. I think it is 2 mm and 0.425 mm. Okay, actually I forgot. Okay, let it be there. Okay, you can just check it. You can just confirm it. Okay, we don't require that. This is why just for the understanding what is fine sand, medium sand, and coarse sand. This is, I'm just giving some introduction. Okay, regarding the size. Let it be there. Now, if it is more than 4.75, we can call it as gravel. Till 80 mm. Okay. So in this particular, they have given that 97% is passing through 4.75. What is the meaning of this? If 97% is passing through 4.75, only 3% can be either gravel or it can be cobble also, or it can be boulder also. These things we don't require actually, just for your understanding. Okay, so definitely it is going to be your sand or silt or clay. How can we check whether it is sand or silt or clay? Here we have to check what is the portion of clay, what is the portion of silt, what is the portion of sand. Whichever is maximum, that will be our major portion. Now see, 17% are passing through 75 micron, which means the remaining 83%, out of this 97% which have passed here, out of this 97% which has passed, in that 97%, only 17% is passing here. The remaining portion is in this sand only. And now the remaining portion of this 97% is actually not remaining 97% of this one. 83% of the total is actually retaining on 75 micron. What is the meaning of this? What is the meaning of this? Very good. This will be sand. The major portion will be sand. Are you understanding what we are telling? Okay, I'm just removing all these things. Understanding? We understood since 97% is passing 4.75 millimeters, we understood that it can be either clay or it can be silt or it can be sand. In that which is majority, that's what we are going to check. How can we check? By looking at the data. They told 83% is actually retaining. This is retained value now, these two columns. 83% have retained on 75 micron, which means only remaining portion will be only 7%, sorry, 17%. That many is passing, that's what we got here. That many only passing 75 micron. So 17% will be combination of clay and silt. We don't know how much is clay, we don't know how much is silt. But obviously this portion is too much. You know, this portion is too much. So that much portion is retaining here. So what we are actually understanding, the soil will be actually sand. Is it clear till here? Okay, yes, 0.425 and 0.2 mm are correct. Okay, thank you. Are you understanding it is sand? Okay, yes. Why we have taken the column of cumulative? Because we want percentage finer. We want to check how much is actually totally it is there. For that, we need to check what is cumulative. And now, have you studied sieve analysis in college? We are getting a graph, something like this, S curve. Cumulative value we are checking, and then we are putting it for percentage finer. Right? Yes, so we understood that it is sand. But if it is a sand, either it can be uniformly graded sand, either it can be well graded sand, or it can be, see, since clay portions are there, no? Either it can be clay sand, either it can be silty sand. Those things we have to check now. Okay, whether it is a silty sand, whether it is a clay sand, and all. Okay, so we have some equations, or sorry, we have some theories for that you have to study a little bit. You have to refer some textbooks. So many points you have to remember actually. If it is, suppose if it is a gravel, how we are actually going to check? If it is a well-graded gravel, the Cu value will be always greater than 4. Okay, and the Cc value should be in between 1 to 3. And if it is a sand, I'm telling if it is uniformly graded. Okay, okay, 1 second. I will write in another way. Yes. A gravel can be uniformly graded. Okay. Then, sorry, well graded. I can put it as GW, sorry. Okay. If it is a well graded gravel, not related to this particular question I'm telling, then Cu value should be greater than 4 and Cc will be in between 1 to 3. And if it is uniformly graded, sorry, if it is poorly graded, then the Cu value may not be, oh, what I can tell, at least one of this is not satisfying. Okay, at least one is not satisfying if they are giving those things in the question. Okay, whether it is poorly graded or well graded, or well graded or poorly graded, if they are asking. Okay, uniformly graded means that curve will be where it is. See, this stands for well graded. If it is excelled down, then it is representing uniformly graded. Those things you can remember. I will show you the equation also. Let it be there. And if it is sand, only one change is there. Instead of this 4, Cu will be greater than 6 for sand. That is the only change. See, Cc value remains same. What is this Cu and Cc? Coefficient of uniformity, coefficient of curvature. The equation I will show you after some time. Okay. So if they are giving in the option, whether it is poorly graded or it is a well graded like that, then we have to check like this. Now, either it can be a silty sand or either it can be a clay sand or silty gravel or clay gravel, whatever, that we can directly check. How can we calculate? For that, we require percentage fines. Okay. So for this actually, to classify like this actually, the percentage finer will be or should be less than 5%. What do you mean by percentage finer? What do you mean by percentage finer? This portion. Okay. Percentage finer means this particular portion. See, 75 micron. That we have to check, that is given as 17%. Whenever this percentage finer is greater than 12%, either our gravel or sand. It can be means coarse grain, na? Sand or gravel. Either it can be clay sand or clayey gravel, or it can be silty gravel or silty sand. In our case, we got it as sand, na? So in our question, either it can be a clayey sand or it can be a silty sand. Why we are going with this? Because the percentage finer we are getting more than 12%. We have percentage finer. How much we got? Percentage finer 17% now. And percentage fines we got here corresponds to 75 micron, because 75 micron is deciding how much clay or silt is there. Okay. Now what we have to do now? We have to check the IP value and we have to check whether it is greater than 7 or not. That is the condition. So many things are there. Atterberg limit will come into picture. So if you have not studied it till now, you may not be understanding what we are discussing, because so many conditions are there. Now, I am discussing based on our data. If you are not knowing it, better you refer the textbook, so that then you can just read the entire thing. Okay, still if you have any confusion after reading it, what you can do in the next sessions and all, you can just ask me in the comment box, so that I can take a question and solve for fine-grained soil classification also. This is for coarse-grained soil classification. That's why we are checking like this. If it is fine-grained soil classification, we are taking some we are taking some water contents. We are going to check whether the limit is greater than 50 or less than 35. So we are going to take some low compressible, medium compressible, high compressible, like that. If you don't know that, you can just comment in the comment box once this video is getting uploaded, after just referring the textbooks or some material. If you don't know, then I will make a question and give you in the part 2 or part 3. Clear? So what we need to do here, whenever it is coming to coarse grained, now we got sand, whatever, whether it is a gravel or clay, gravel or sand, whatever it is, we have to check the IP value. What is the IP value? WL minus WP. How much it is? How much it is? WL minus WP, we already calculated that as 18%. If this is greater than 70%, if IP is greater than 7 and Atterberg limit is above, or our thing is Atterberg limits are above a line, we'll go for clay. If not, we are going, or if IP value, if it is less than 4%, if it is less than 4%, and Atterberg limit is below a line, we'll go for silty or silty sand. According to this case, I can put it as like that. Okay. Consistency index. Okay, I can explain. Don't worry. That after this question, I will explain. Okay. So in this question, how much we got? IP as 18%. So which one it will be? We got 18%. So which one it will be? Will it be clay sand or silty sand? Obviously, we are going to go with clay sand. Understood? See, if you have already studied this, you will understand. If you have not studied this, it's like a lot of concepts are there. Everything is difficult to explain again. So what you can do, just refer the textbook if you have not studied till now. Okay, just refer that. Then what you can do, if you still don't understand how we are going to classify, I can take another question particularly for this classification, and I will do that in the second part or third part. It depends on your response. Okay, that's it. Clear? So how we are going to represent this gravel? How we are going to represent sand and all? Clay sand and silty sand? Silty sand and clay gravel. See, should we, so GM is obviously wrong, G for gravel. Whether this is correct or not, everyone please comment. Is this the way I should represent clay sand, or is it CS, clay sand? No? So it should be CS or SC. Is it clear? Or it should be SM. M will come if it is silty. Okay, we are writing. We need clay. Okay, so is it SC or CS? SC. Very good. So this is absolutely correct. Now that also can be the twist. Sometimes they can give CS. That representation is wrong. Okay. We are putting SC, GC like that. GM. Understood? That's it. Okay. So here we will be getting A as correct. Also D as correct. Clear, guys? Now let me check. Yes. I will tell you some points since our session timing is winding up. Some points, just some points. Cu we have already written, nothing but coefficient of uniformity. D60 divided by D10. Obviously, Cu value will be always greater than or equal to 1 because your D60 will be always greater than D10. Coming to Cc, nothing but coefficient of curvature is nothing but D30 square divided by D10 into D60. Okay, that you can check. I have just written some points also. You can take a screenshot or later you can check it. Now the terminal velocity, sometimes they can ask you, it's not that much important, but it is coming in environmental engineering and all, I guess. Yes. So you might have, sometimes you might have already studied. In geotechnical engineering also, we can study it, terminal velocity. We are calculating using Stokes law. So if you want to use Stokes law, very important, that itself can be asked for 1 mark. We can use only if the particle size is in between 0.2 micron to 0.2 mm. 0.2 micron, we can also write it as 0.0002, right? 0.2123, yes. Mm to 0.2 mm. This is very important to use the Stokes law. Okay, you can use this equation directly. So if you want to use this, any equation you can use. All these equations are similar. Okay, all these equations are similar. Yes, all these equations are similar. You can just compare it. Unit weight of solid, unit weight of water. Then we know the equation for unit weight. Unit weight is nothing but density into acceleration due to gravity g. So if I am taking, simply writing, okay, if you are writing rho g, which means I can take that g out, then I can put it as rho s minus rho w. Have you studied this? Have you studied this concept in environmental? Can you please confirm? I have studied it long before. Can you please confirm whether it is 0.2 mm or 2 mm? Can you please confirm and let me know in the comment box? 0.2 mm in my memory. If I'm wrong, please correct me in the comment box so that we can just correct it now itself. Yes. So rho g, we can put it here. Then we'll be getting this one. Now see, we know what is specific gravity. Specific gravity is nothing but divided by whatever it is. Okay, rho s divided by rho w. Or simply gamma s divided by gamma w. So if you are doing this directly, we are getting the third one also. Okay. Now only thing is the final one you may be getting a little bit confusion. Simply this mu stands for kinematic. Sorry. 1 second. This mu stands for dynamic viscosity. You might have already studied this in some other chapters and all, maybe in fluid mechanics or somewhere in hydrology, well hydraulics. I have just mentioned this somewhere. So mu is dynamic viscosity that we are substituting here. The kinematic viscosity, whatever be the symbol you are using, that is nothing but the dynamic viscosity divided by density of water. Okay. So what we are actually having here, sorry, I think I made a mistake. I think I made a mistake. I think it will, that G will not be there, I guess. Okay, we will confirm that in the next session. Okay, I think I made some mistake there. Do you remember whether it is gamma W or rho? I don't have anything to confirm now. Okay, this is fine, only 0.2. Okay, fine. Okay, some mistake is there, I guess. It will not be gamma W or rho W, I forgot. If it is rho W, then G will not be there. Okay, as simple as that. So we are getting completely opposite. You can just check that, okay? It is completely opposite. We require mu divided by rho W. Rho W or gamma W. I just wanted to confirm that. Okay, it's rho in the sense, okay, then this G may not be there. Okay, may not be. You just check it. Sorry. So we require the complete opposite thing so that dynamic viscosity, so kinematic viscosity will come down. This symbol stands for kinematic viscosity. Kinematic viscosity. Okay. So if they are giving the dynamic viscosity in the question, use this one. If they are giving the kinematic viscosity, then properly you have to convert. Just check it, okay, whether it is rho or gamma. In my memory, it is rho only, so that G may not be there. Then you can use that one also. Clear? That also they can ask. Okay, I think it is rho only, the density, okay, not the unit weight. Long before I studied, directly I was just before the session I was writing this, that's why. Understood? So these points you just remember. Then the remaining concept we can just look it into the next session. Next session onwards, we are going with these questions and all regarding some excavation. We'll study a lot of things. We are going to study effective stress, seepage pressure, everything in the coming session. So right now we are winding up, and I hope this session was beneficial for you. See, if anyone, anything, if you have doubt, you can just ask me regarding this particular session. Regarding other topics, which we can discuss in some other, I mean, in the next session or the other sessions. If you have any doubt, you can just ask me now. Yeah, thank you, Neeru, for your comment. Anything if you want to know, you can just ask now. If any doubt regarding this, but whatever we have studied till now, okay? Yeah, Naresh, please ask. Whatever doubt if you have, you can just ask me. I can just come. Okay, just maximum some 5 minutes we may take. Otherwise, you can just comment in the comment box. Once this video is getting updated, then you can just ask it. Okay. Consistency index. Okay, consistency index is very easy. 1 second. Yes. So consistency index, very easily we can calculate consistency index, very directly formula based thing. If they are giving any value of water content, okay, generally we used to calculate in between only this range, liquid limit minus the given water content, okay, or the natural water content I can put. So simply W. The liquid limit minus that any water content that they are giving divided by the plasticity index. What is plasticity index? WL minus WP. Okay, so it is defined for here only, in between some value. Denominator is nothing but your plasticity index. Okay, just remember, this is how I used to remember. Just remember a W value somewhere here. Sorry, W value somewhere here. So for consistency, we are looking right side. For plasticity index, we are looking left side. So plasticity index will be, this is consistency index. Then what will be liquidity index? Not plasticity index. Plasticity index is this denominator. This one is consistency index. Then liquidity index. These are very direct formula based only, okay? Liquidity index, I don't know how I should give the, okay, simply IL or something. Nothing but W minus WP divided by plasticity index. Denominator is same, okay, plasticity index. Only thing is the numerator will change, WL minus W for consistency index, and W, the given water content minus WP for liquidity index. Is it clear? Yes, I can provide these notes, don't worry. We'll update. Somehow you should be getting that PDF actually. If you are not able to, I don't know how you'll be getting it. Let's see. Okay. Maybe once this video is getting uploaded, maybe in the comment box, they will add. Maybe the comment box is not public now. That's why you may not be able to see it. Okay. The PDF we will give. Don't worry. So I hope no more. Okay. The PDF actually will be updated in the description, okay, in a couple of days. Whatever video thumbnail you are seeing now in our channel. So you just go to the description box, whatever we have done, transportation we completed, hydrology we completed, structures, Abhijit sir has taken. So like that, so many sessions you have already got. So those who have already completed, I mean, which all sessions are there, which are already completed, you just go to that video. In the description box, the link will be added. From there, you can just directly download it. Okay, don't worry. Okay, so I hope no more doubts are there. Capillary and all I will discuss. Okay, Krishna, I will check that solution and all in the next session. Right now, I have to check the answers. Okay, so yes, so I'm not getting any more doubt. So shall we wind up? So I hope this session was beneficial for you. Right, so if you feel the session was good, okay, please show your love in terms of likes and comments and share the link with your friends. Let your friends also study. So in all my sessions, I used to say like share the links with your with your friends and colleagues. Don't think that they will also study and they will get more mark than me. Don't think like that. You can also study in IIT. Your friend also can sit nearby you and study with you. That's a good thing now. So help your friend also. Share the link with your friends and your classmates. Let them also study and take more mark like you. Study together in IIT, study together in NIT, study, work together in PSU. That's it. Okay. So that's it. Once again, please subscribe the channel and click on the bell icon also. Whenever now onwards, you will be getting a lot of videos. Okay. How to manage the time, how to use, make use of the time, and like there's so many things you will be getting. So click on the bell icon also. You will be getting the notification. That's it. So bye everyone. Thanks for joining the session. Thanks for watching the video. Bye. Take care. Good day.